Hello, in this lecture we will find the area of a circle. In the drawing we have a circle, and inside the circle we have a shape, and two angles of this shape are right angles. Angle ADC is a right angle, it equals to 90 degrees, and also angle BCD is a right angles, it equals to 90 degrees. And also we know that side AD of this shape is 4 units in size, and side DC is 6 units in size, and side CP equals to 8 units in size. Okay, and we want to find out the area of this circle. First of all, I will explain you the theorem of one-sided angles. Okay, what is one-sided angle? If we have two lines, line A and line B, okay, we have two lines, line A and line B, and the third line, line C, that intersects with those two lines line C in the red color, line C in the red color intersects with line A at point, let's say point M, while line C intersects with line B at point N. Then actually we have here two one-sided angles, angle alpha and angle beta are considered or defined as one-sided angles. I write it down. Angles alpha and beta are interior one-sided angles. Again, angles alpha and beta are defined as interior one-sided angles, and actually they are called one-sided angles because both of them are located from one side of the red line C. Both of them are located on the left side of line C. For that reason, they are called one-sided angles, and they are internal because both alpha and beta are inside lines A and B. Okay, so alpha and beta are defined as interior one-sided angles. Okay, and we actually have the other possibility of exterior one-sided angles. So if we have two lines, line A and line B, this is line A, and this is line B, and we have a third line, line C, that intersects with those two lines, line C, in the red color, intersects with those two lines at points, let's say points M and N, and N is the point of intersection between line A and line C, and also here M is the point of intersection between line B and line C. So actually angles alpha and beta, those two angles alpha and beta are defined as exterior one-sided angles. Okay, those two angles alpha and beta are defined as exterior internal exterior one-sided angles. Again, angles alpha and beta are defined as exterior one-sided angles. Again, because of the fact that angles alpha and beta, both of them are located on the left side of line C, they are called one-sided because they are both on one side, that is to say on the left side of line C, and also because of the fact that both of those angles alpha and beta are located outside lines A and B, they are defined as exterior. Okay, so those two angles are defined as exterior one-sided angles. Okay, so actually that is the definition of one-sided exterior or interior angles. Those two angles are defined as interior one-sided angles, while those two angles are defined as exterior one-sided angles. Okay, and actually we have a rule, I will call it rule number 1, for one-sided angles. It doesn't matter if they are interior or exterior. We have a rule number 1, that states if the sum of the two one-sided, they can be internal or external, or interior or exterior, it doesn't matter. So if the sum of two one-sided angles is equal or equals to 180 degrees, then line A is parallel to line B. So I will read rule number 1 again. Rule number 1 states that if the sum of two one-sided angles equals to 180 degrees, then line A is parallel to line B. So actually here if alpha plus beta equals to 180 degrees, then line A is parallel to line B. And also here, if alpha plus beta equals to 180 degrees, then line A is parallel to line B. So I will write it down. If alpha plus beta, the sum of those two one-sided angles, one-sided interior angles, equals to 180 degrees, then line A is parallel to line B. Okay, if the sum of alpha plus beta is 180 degrees, then line A is parallel to line B. The same rule apply for the exterior internal angles. That is to say, if alpha plus beta equals to 180 degrees, then line A is parallel to line B. Okay, that is actually rule number 1. According to rule number 1, okay, here also the same rule. If the sum of alpha plus beta equals to 180 degrees, then according to rule number 1, line A is parallel to line B. So again, if rule number 1 states that if the sum of two one-sided angles equals to 180 degrees, then line A is parallel to line B, and it doesn't matter at all if those two one-sided angles are internal angles or interior angles or exterior angles. The same rule apply to both of them. If the sum of alpha plus beta equals to 180 degrees, then line A is parallel to line B. It applies to the interior angles and also to exterior angles. Okay, so actually we can implement rule number 1 in our circle. Because we have line segment AD and line segment BC, and also line segment DC that intersects with line segment AD at point D, and line segment AD intersects with line segment BC at point C. Okay, so actually we can view line segment DC as line C, and those two angles, those two right angles, are internal one-sided angles. Okay, why they are one-sided? Because both those two angles are from the left side of line segment DC, and they are internal because both those right angles are inside the line segment AD and line segment BC. So we can see in the drawing that the sum of those two right angles, angle ADC equals to 90 degrees, and angle BCD, angle ABCD or BCD, this angle also equals to 90 degrees. So actually 90 degrees plus 90 degrees equals to 180 degrees. Okay, the sum of those two right angles is 180 degrees, and the main point is that they are internal one-sided angles. The sum of those two angles are 180 degrees. 90 degrees plus 90 degrees equals to 180 degrees, and they are defined as interior one-sided angles. Okay, so I write it down, and they are interior one-sided angles. Okay, those two angles are interior one-sided angles, and the sum of those two angles is 180 degrees. Therefore, according to rule number 1, rule number 1 states that if the sum of the two one-sided angles equals to 180 degrees, then line A is parallel to line B. So we can deduce from rule number 1 that AD is parallel to BC, because actually DC is considered as line C that intersects with this line as at point D, and with the other line with at point C. So according to rule number 1, because of the fact that those two one-sided interior angles, the sum of them equals to 180 degrees, we can deduce from it, according to rule number 1, that AD is parallel to BC. Okay? Line segment AD is parallel to line segment BC. Okay? Again, the sum of those two one-sided angles is 180 degrees. So according to rule number 1, line segment AD is parallel to line segment BC. Okay? So in the next step, we will connect together points A and C by a straight line. And we will also connect together points D and B by a straight line. And we will define the point of intersection between line segment AC and line segment DB as O. Again, point O is the point of intersection between line segment AC and line segment DB. Okay? And we will focus on triangles POC and triangles AOD. Okay? We will focus on the green triangle BOC. And the green small triangle AOD. On those two green triangles, so I'll write it down. We will focus on triangles AOD and triangle BOC. Two green triangles. On those two green triangles, angle AOD, this angle is equal to angle BOC. Those two angles are equal to each other. I write it down. Angle AOD is equal to angle BOC. According to the new rule number 2, that vertex angles are equal to each other. So those two angles are vertex angles, and we have rule number 2 that states that vertex angles are equal to each other. Again, angle AOD equals to angle BOC. This angle equals to this angle, according to the rule that vertex angles are equal to each other, rule number 2. Okay, so now I will explain the term vertex angles. Actually, if we have two lines that are intersecting each other, two lines, for example, line A intersects with line B, and this is the point of intersection between those two lines, then they actually create four angles. This is angle number 1, and this is angle number 2, this is angle number 3, and this is angle number 4. Okay, whenever two lines are intersecting each other, then at the point of intersection they create four angles. 1, 2, 3, 4. Okay, and actually angles 1 and 3 are defined as vertex angles and they are equal to each other. So I write it down. Angles 1 and 3 are defined as vertex angles. And according to the new rule number 2, it states that vertex angles are equal to each other. They are equal to each other. So I read it again. Angles 1 and 3 are defined as vertex angles, and according to rule number 2, they are equal to each other. And also we have the second pairs of angles. Angles 2 and 4 are defined as angles, as vertex angles. Angles 2 and angle 4 are defined as vertex angles, and therefore according to rule number 2, they are equal to each other. I read again. Angle 2 and angle 4 are defined as vertex angles, and according to rule number 2, they are equal to each other. So now I write down rule number 2. Rule number 2 states that vertex angles are equal to each other. I will read again rule number 2. Rule number 2 states that vertex angles are equal to each other. So we actually have two pairs of vertex angles. Whenever two lines are intersecting each other, at the point of intersection, two pairs of vertex angles are created. The first pair of vertex angles as the second pair of vertex angles, they are equal to each other. So those are the first pair of vertex angles, and according to rule number 2, they are equal to each other. So alpha and beta are vertex angles, and therefore according to rule number 2, they are equal to each other. Okay, alpha and beta are defined as vertex angles, and according to rule number 2, they are equal to each other, and the second pairs will be those two angles. I will draw it again. So those angles are the first pair of vertex angles that are equal to each other, and the second pair of vertex angles are those angles, and according to rule number 2, they are also equal to each other, so I write it down. Alpha and beta are vertex angles, so according to rule number 2, they are equal to each other. Okay, alpha and beta are defined as vertex angles, and according to rule number 2, they are equal to each other. That is to say, alpha equals to beta. Okay, those are the second pair of angles, of vertex angles that are equal to each other, and those pair are the first pair of vertex angles that according to rule number 2 are also equal to each other. Okay, so actually you can actually implemented rule number 2 in our circle, because those two angles, angle AOD and angle BOC, those angles are vertex angles, so according to rule number 2, they are equal to each other. So I write again. Again, in the green triangles, angle AOD equals to angle BOC, because they are vertex angles, and according to rule number 2, vertex angles are equal to each other. Okay? Then you actually have another type of angles that are defined as alternating angles. If we have two lines, line A and line B, if we have two lines, line A and line B, and the third line, line C, intersects with those two lines, this is the point of intersection between line C and line B, and this is the point of intersection between line A and line C. Then angles alpha and beta are defined as interior alternating angles. So I write it down. Angles alpha and beta are interior alternating angles. Okay, angles alpha and beta are defined as interior alternating angles. First of all, why those two angles are defined as alternating angles? They are defined as alternating angles because they are on opposite sides of line C. Angle alpha is on the left side, located on the left side of line C, while angle beta is located in the right side of line C. For that reason, angles alpha and beta are defined as alternating angles. Okay, and they are interior angles because they are both inside lines A and B. So for that reason, they are actually interior alternating angles. This is one type of alternating angles, and we have also the other type of alternating angles that are defined as exterior alternating angles. And we also have rule number 3 for those alternating angles. First of all, I will show you the exterior alternating angles. If we have two lines, line A and line B, and we have the third line, line C, okay, we have two lines, line A and line B, and we have the third line, line C, that intersects with those two lines. Line C intersects with line B at this point, while line C intersects with line A at this point. Then those angles, angle alpha and angle beta, are defined as exterior alternating angles. As you can see in the drawing, we have angles alpha and angles alpha and beta are located on the opposite sides of line C. In relation to line C, angle alpha is located in the opposite side of angle beta, while angle beta is located in the right side of the line C. Angle alpha is located in the left side of line C. For that reason, they are defined as alternating angles, and for the reason that angles alpha and beta are outside line A and B, they are defined as exterior angles. So those angles, angles alpha and beta, are defined as exterior alternating angles. Okay, those two angles are exterior alternating angles, while those two angles are defined as interior alternating angles. Okay, again, they are alternating angles because both those two types of angles are located at the opposite side in relation to line C. They are located in the opposite side in relation to line C here, and also those two angles are located in the opposite side of, in relation to line C. Okay, so that is the definition of alternating angles. Those two angles are interior alternating angles, while those two angles are exterior alternating angles. And as I've already told you, we have rule number 3 for alternating angles. Rule number 3 states that alternating angles, no matter if they are interior or exterior, between parallel lines are equal to each other. So I will read rule number 3 again. Rule number 3 states that alternating angles between parallel lines are equal to each other. So actually here if A is parallel to B, if line A is parallel to line B, then according to rule number 3, angle alpha equals to angle beta. Okay, only if line A is parallel to line B, only then we can use rule number 3 that states that alpha equals to beta. Okay, only if line A is parallel to line B, alpha equals to beta. Otherwise, it is not true. Okay? Otherwise, alpha doesn't equal to beta if A is not parallel to B. And also here, only if line A is parallel to line B, only if line A is parallel to line B, then angle alpha equals to angle beta. So alternating angles are equal to each other only if they are between parallel lines. That is exactly what rule number 3 states. Only if they exist between parallel lines, only then they are equal to each other. So only if line A is parallel to line B, only then angle alpha equals to angle beta. Very important point to emphasize. Only if the lines are parallel to each other, only then the alternating angles are equal to each other. Okay? So we actually can implement rule number 3 in our circuit because we have already proved, according to rule number 1, that line segment AD is parallel to line segment BC. Okay, we know that AD is parallel to BC according to rule number 1. So actually we have angle OAD angle OAD is alternate angle, why angle OAD is an alternate angle? Because it is located between those two parallel lines. And also angle BOC, angle BCO. So actually the pair of those two angles are alternating angles. First of all, why they are alternating angles from the beginning? Because of the fact that they are located on the opposite sides of line segment AC. Okay, those two angles are located on opposite sides of line segment AC. For that reason, they are defined as alternating angles. And they are also interior alternating angles because they are inside line segments BC and AD. Okay, so we know that line segment BC is parallel to line segment AD. So actually those two alternating angles located between parallel lines. So according to rule number 3, alternating angles between parallel lines are equal to each other. For that reason, angle AOD equals to angle BCO. Okay, so write it down. Angle DAO equals to angle BCO. Those two angles are equal to each other because they are actually alternating angles. They are located in opposite sides in relation to line segment AC. Okay, and they are located between those two parallel line segments. Therefore, according to rule number 3, they are equal to each other. Okay, alternating angles, rule number 3. Again, angle DAO equals to angle BCO according to the rule that alternating angles between parallel lines are equal to each other. That is rule number 3. According to rule number 3, those two angles are equal to each other because they are alternating angles that are located between those two parallel line segments, and therefore they are equal to each other according to rule number 3. And also we have angle CBO and angle ADO are also two alternating angles. Those two angles are located on opposite sides in relation to line segment DB. Okay, they are located on the opposite sides in relation to line segment DB. for that reason they are alternating angles. That is the definition of alternating angles. And they are interior alternating angles because they are located between line segment BC and AD. And because of the fact that line segment BC is parallel to line segment AD, according to rule number 3, they are equal to each other. Because rule number 3 states that alternating angles between parallel lines are equal to each other. Okay, so for that reason, angle CBO equals to angle ADO. Because they are two alternating angles, because they are located on opposite sides according in relation to line segment DB, and they are located between parallel line segments. AD is parallel to BC, so according to rule number 3 they are equal to each other. Okay, so angle CBO equals to angle ADO because they are alternating angles between parallel lines, so according to rule number 3 they are equal to each other. Okay, according to rule number 3 they are equal to each other. Okay, so we actually proved in relation to those two green triangles, we proved that those angles are equal to each other, and also we proved that those two angles are equal to each other, and we have already proved that those two angles are equal to each other. Therefore we proved that three angles, all the angles in this green triangle are equal to all those three angles in the green small triangle. Therefore, according to the rule that if you prove that three angles in one triangle are equal to three angles in the other triangle, then you actually proved that the triangles are similar to each other. So according to angle AAA, A is abbreviation for angle, triangle, the big green triangle BOC, is similar to the small green triangle AOD. Okay, so write it again. According to angle, triangle BOC is similar to triangle AOD. Okay, triangle BOC is similar to triangle AOD. and in case that two triangles are similar to each other, we have special relationship between their sides that is true. If we have two triangles that are similar to each other, for example, if we have those two triangles, the big triangle ABC is similar to the small triangle TEF, that is to say, three angles of the big triangle are equal to three angles of the small triangle, then the following relationship between the sides of those two triangles is true. AB over DE equals to BC over EF equals to AC over DF over EF. So I will read again the equality that exists between two similar triangles, between the sides of two similar triangles. AB over DE equals to BC over EF equals to AC equals to AC over DF. I read again, AB over DE equals to BC over EF equals to AC over DF. Okay? So this equality between the sides of those two triangles is true. So we actually can implement this equality in our two green similar triangles. Okay, AB over DE equals to BC over EF equals to AC over DF. Okay, so we will implement this equality in our two green similar triangles. OB over OD equals to OC over OA equals to BC over AD. So I read again the equality. OB over OD, OB over OD equals to OC over OA equals to OC over OA equals to BC over AD equals to BC over AD. But we know that BC equals to 8 units, so I write it here, BC equals to 8 units, while AD equals to 4 units. So we can write here, AD equals to 4 and BC equals to 8. 8 over 4 is 2. So we have this equality. So the first equality is OB over OD equals to 2. OB over OD equals to 2. We'll multiply this equality by 2, by OD. We'll get that OB equals 2 times OD. OB equals 2 times OD. OB equals 2 times OD. So if OD equals to A, then OB equals 2 times OD. That is to say, OB equals 2 times A. And we have the second equality that states that OC over OA equals to 2. So we can multiply this equality by OA. We'll get that OC equals 2 times OA. So OC equals 2 times OA. So if OA equals to B, then OC equals 2 times OA. OC equals 2 times B. Okay? OC equals 2 times OA. So if OA equals to B, OC equals 2 times OA. OC equals to 2 times B. Okay, so in the next step, we will focus actually angle ADC equals to 90 degrees. Therefore, triangle ADC is a right triangle. Angle ADC is a right angle. Therefore, triangle ADC is a right triangle. Okay, angle ADC equals to 90 degrees. Therefore, triangle ADC is a right triangle. And in any right triangle, we can use the Pythagorean theorem. The Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So we can implement this Pythagorean theorem in this right triangle, the square of the hypotenuse equals to AC square the square of the hypotenuse equals to the sum of the squares of the perpendiculars equals to AD square plus DC square. Okay, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. What is the value of AC? The value of AC equals to B times 2B. Okay, B plus 2B, AC equals to B plus 2B, or AC equals to AO plus OC, and AO equals to B, while OC equals to 2B, so AC equals to 3B. So we can write that AC equals to 3B. AC square is 3B square. AC square, because of the fact that AC equals to 3B, then AC square equals to 3B square. While AD equals to 4, so AD square is 16 plus DC square. DC equals to 6, so DC square is 36. So in total we got that 3B square equals to 16 plus 36. 16 plus 36 is 52, so I write it down. So we got that 3B square equals to 52. Now I will take a root out of this equality. We got that 3B equals to the root of 52. 52 equals to 13 times 4. And we can also split the root to two roots, according to the rule that the root of A times B equals to root A times root B. So we got that 3B equals to the root of 4 times root of 13. Root of 4 is 2, so I write it down. So we got that 3B equals 2 times root 13. I will divide this equality by 3 and we will get the value of B. B will be equal 2 over 3 times root 13. So we divided this equality by 3 and we got that b equals to 2 over 3 times root 13. If b equals to 2 over 3 times root 13, then 2 times b equals to 4 over 3 times root 13. So I write the value of b. b equals to 2 over 3 times root 13. While 2 times b equals to 4 over 3 times root 13. Okay. Actually, angle BCD is a right angle. It equals to 90 degrees. Therefore, triangle BCD is a right triangle. In the right triangle BCD, we can implement the Pythagorean theorem. I will repeat again on the Pythagorean theorem. The Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse in the right triangle BCD is dB. dB squared equals to the sum of the squares of the perpendiculars equals to BC squared plus BC squared. So again, the implementation of the Pythagorean theorem in the right triangle BCD is BD squared, that is to say the square of the hypotenuse equals to BC squared plus DC squared, that is the sum of the squares of the perpendiculars. Okay, what is the value of dB? What is the size of dB? dB equals to OB plus OD, okay? Yes? dB equals to OB plus OD. It is 2A plus A. That is to say, dB equals to 3 times A. 3 times A. So, dB square will be equal to 3 times A square equals to BC square. BC equals to 8, so BC square is 8 square is 64 plus DC square. DC equals to 6, so 6 square is 36. In total we got that 3 times A square equals to 64 plus 36. 64 plus 36 is 100, so I write it down. Okay, we got that 3 times A square equals to 100. Now I will take a root out of this equality. We'll get that 3 times A equals to 10. So we took a root out of this equality. The root of 100 is 10, so 3a equals to 10. I will divide this equality by 3 and we will get the value of a. Actually, a equals to 10 over 3 units. Okay, I divided this equality by 3. We got that a equals to 10 over 3 units, while if a equals to 10 over 3 units, then 2 times a will be equal to 20 times 20 over 3 units. Okay, so I write the values that we got in the drawing. A equals to 10 over 3 units, while 2 times a equals to 20 over 3 units. Okay, so I will copy this drawing with the values of the line segments without the variables a and b. Okay, AO equals to 2 over 3 times root 13, while OC equals to 4 over 3 times root 13, OD equals to 10 over 3 units, while OB equals to 20 over 3 units. Okay, so we actually know the values of all the line segments inside the circle. In the next step, we will extend line segment AC until it touches the circle at point P. The point of contact between the circle and the chord AP is at point P. Then we created new line segment CP, and we'll calculate the value of line segment CP according to the new rule, rule number 4. Okay. Actually, rule number 4 states that if we have two chords that are intersecting each other at point O, chord AB intersects with chord CD, chord AB intersects with chord CD at point O. The point of intersection between chord AB and chord CD is at point O. Then the following inequality is true. AO times OB equals to CO times OD. I write it down. AO times OB equals to CO times OD. I'll repeat again on rule number 4. If we have two chords, chord AB and chord CD, that are intersecting each other at point O, then the following equality is true. AO times OB equals to CO times OD. Okay, so I write down rule number 4. So actually rule number 4 states that if two chords chord AB and chord CD are intersecting each other and the point of intersection is at point O, then the following equality is true. AO times OB equals to OC times OD. So I will read rule number 4 again. If two chords AB and CD, chord AB and chord CD are intersecting each other at point O. The point of intersection between chord AB and chord DC is at point O. Then the following equality is true. AO times OB equals to OC times OD. AO times OB equals to OC times OD. Okay, so we actually can implement rule number 4 in our circle in order to find out the value of the line segment CP. In our drawing, we have chord AP that intersects with chord DB at point O. I write it down. Chord AP intersects with chord DB at point O. Again, the point of intersection between chord AP to chord DB is at point O. Therefore, according to rule number 4, whenever two chords are intersecting each other, then we can implement rule number 4. Two chords that are intersecting each other at a circle, if we have this reality, then we can implement rule number 4 in the circle. According to rule number 4, therefore according to rule number 4, AO times OP equals to DO times OB. Again, AO times OP equals to DO times OB. So I read again the things that I wrote. Chord AP intersects with chord DB at point O. Chord AP intersects with chord DB at point O. Point O is the point of intersection. Therefore, according to rule number 4, AO times OP equals to DO times OB. Okay, AO times OP equals to DO times OB. AO equals to 2 over 3 times root 13. while OP equals to OC plus CP equals to DO. DO equals to 10 over 3 units times BO or OB that equals to 20 over 3 units. So in total we got that 2 over 3 times root 13 times OP, and OP equals to OC plus CP, OP equals to OC plus CP equals to DO is 10 over 3 units times BO is 20 over 3 units. Okay, here OC plus CP is actually 4 over 3 times root 13 plus CP. So I write it down. OC is 4 over 3 times root 13 CP is the line segment that is missing, and we want to find out the value of it, so we'll leave it as it is. Equals to 10 times 20 is 200. 200 over 3 times 3. Okay. In this equation we have 3 in the denominator of this side of the equality, and we have 3 in the other side of the equality, so we can cancel 3 because we have 3 in both sides of the equality. So what is left is 2 times root 13 times 4 over 3 times root 13 plus CP equals to 200 over 3. So I will open the brackets here. Here 2 times 13 times 4 times 13, root 13 times root 13 equals to 13. So in total we will get 2 times 4 is 8 times 13 over 3 plus 2 times root 13 CP equals to 200 over 3. So in total we got that 8 times 13 over 3 equals to or plus 2 times root 13 times CP equals to 200 over 3. Now 8 times 13 is 104, so I write it down. So again, 8 times 13 is 104. In total we got 104 over 3 plus 2 times root 13 times CP equals to 200 over 3. here we will subtract 103 from this equality, 104 over 3 from this equality. In total, we got that 2 times root 13 times Cp equals to 200 minus 104 over 3. 200 minus 104 equals to 96, so I write it down. So we got in total that 2 times root 14 times Cp equals to 96 over 3. 96 over 3 equals to 32. So I write it down. In total we got that 2 times root 13 times Cp equals to 32. Here we can divide this equality by 2. So we got that root 13 times Cp equals to 16, root 32 over 2 is 16. We will divide this equality by 13 and we will get the value of Cp. Okay. So we divided this equality by root 13 and we got that the value of line segment Cp equals to 16 over root 13 units. Okay, so we found out the value of Cp. The value of Cp is 16 over root 13 units. Okay. In the next step, we will extend line segment DC until it touches the circle at point R or point Q. We will extend line segment DC until it touches the circle at point Q. Okay, we extend that line segment DC until it touches the circle at point Q. Q is the point of contact between the line segment and the circle. We created chord DQ and new line segment CQ. that we'll find the value of line segment CQ again according to rule number 4. As you can see from the drawing, line segment DQ intersects with line segment AP, line segment DQ intersects with line segment DQ at point DP at point C. Point C is the point of intersection between chord DQ and chord AP. I will write it down. Chord DQ intersects with chord AP at point C. So point C is the point of intersection between chord DQ to chord AP. So according to rule number 4, AC times CP equals to DC times CQ. We'll read again the things that I wrote. Chord DQ intersects with chord AP at point C. Chord DQ intersects with chord AP at point C. C is the point of intersection between those two chords. So according to rule number 4, AC times CP, AC times CP equals to DC times CQ. Okay? AC equals to 2 over 3 times root 13 plus 4 over 3 times root 13. While CP, we know we have already calculated the value of line segment CP. It equals to 16 over 13 over root 13 units. All equals to DC. DC equals to 6 units times CQ. CQ is the line segment that is missing and we want to find out the value of CQ, so I will leave it as it is, 6 times CQ. So in total we got that 2 over 3 times root 13 plus 4 over 3 times root 13 times 16 over root 13 equals to 6 times CQ. 2 over 3 times root 13 plus 6 over 3 times root 13 equals to 6 over 3 times root 13, so I write it down. So in total we got that 6 over 3 times root 13 times 16 over root 13 equals to 6CQ. We have here in this side of the equation root 13 in the numerator, and we have also root 13 in the denominator. So root 13 is cancelled, and 6 over 3 is 2. So in total in this side of the equation we have 2 times 16 equals to 6 times CQ. So I write it down. So in total we got that 2 times 16 equals to 6 times CQ. 2 times 16 is 32, so I write it down. Okay, we got that 32 equals to 6 times CQ. I will divide this equality by 6 and we will get the value of CQ. CQ equals to 32 over 6. Okay, 62 equals to 32 over 6. We can divide the numerator and the denominator in this number by 2, and we will get that CQ equals to 16 over 3 units. So we found out the value of line segment CQ. CQ equals to 16 over 3 units. So we can write here that CQ equals to 16 over 3 units. Okay, in the next step we will extend line segment BC until it touches the circle at point R. Okay, we extended line segment BC until it touches the circle at point R. Point R is the point of contact between the line segment to the circle. So we created chord BR, and we also created the new line segment RC, and we again will find the value of line segment RC according to rule number 4. Actually, chord RB intersects with chord DQ at point C. Point C is the point of intersection between chord TQ to chord RB. Therefore, we have two chords that are intersecting each other. When we have two chords that are intersecting each other at the circle, we automatically can implement rule number 4 on the circle. So according to rule number 4, DC times CQ equals to BC times RC. Okay, DC times CQ equals to BC times RC, according to rule number 4. DC equals to 6 units, CQ equals to 16 over 3 units, all equals to BC equals to 8 units, while RC is the missing variable, missing line segment that we want to find out the value of it, so I will leave it as it is. In total, we got that 6 times 16 over 3 equals to 8 times RC. 6 over 3 is 2, so I write it down. So we got that 2 times 16 over 3 is 2, so we got that 2 times 16 equals to 8 times RC. 2 times 16 is 32, so I write it down. So we got that 32 equals to 8 times RC. We will divide this equality by 8 in order to find out the value of RC. So 32 over 8 is 4, so we got that RC equals to 4 units. So we can write here that RC equals to 4 units. So we actually have all the values of all the line segments in this circle, and the only missing thing is the radius of this circle. In order to find out the radius of this circle, we will implement rule number 5 on this circle. Actually, rule number 5 states that if two chords are intersecting with each other at 90 degrees, for example, we have chord AB, that intersects with chord CD, chord AB intersects with chord CD at 90 degrees. So at the point of intersection, we'll call the point of intersection point O, and actually at the point of intersection chord DC creates 90 units with chord AB. Actually all the four angles here equals to 90 degrees. So if this is the reality, then the following equality is true. 4 times r squared, r is the radius of this circle, equals to AO squared plus OB squared plus CO squared plus OD squared. 4 times r squared equals to AO squared plus BO squared plus CO squared plus DO squared. I will repeat again on rule number 5. Rule number 5 states that if two chords, chord AB and chord CD, are intersecting each other at point O at 90 degrees, they create 90 degrees in the point of intersection between them, then the following equality is true, that 4 times the radius of the circle squared equals to AO squared plus OB squared plus CO squared plus DO squared. So I will write down rule number 5. So rule number 5 states that if two chords are intersecting each other at 90 degrees, are intersecting each other at 90 degrees, and the point of intersection is point O, the point of intersection between those two chords A, B and CD is at point O, then the following equality is true. Four times r squared, when r is the radius of the circle, equals to AO squared plus BO squared plus CO squared plus DO squared. So I will read again rule number 5. Rule number 5 states that if two chords A, B and CD are intersecting each other, chords AB intersects with chord CD, if two chords A, B and CD are intersecting each other at 90 degrees, they create at the point of intersection 90 degrees with each other. All the angles here, all the four angles are equal to 90 degrees. And the point of intersection is point O. Point O is the point of intersection between those two chords. Then the following equality is true. 4 times r squared when r is the radius of the circle equals to OA squared plus BO squared plus CO squared plus DO squared. 4 times r squared when r is the radius of the circle equals to OA squared plus BO squared plus CO squared plus DO squared. Okay? Okay, so we actually can implement, so actually whenever we have two chords that are intersecting with each other at 90 degrees, then we can implement rule number 5 on the circle. Okay, and actually we can implement rule number 5 in our circle because actually angle BCD equals to 90 degrees. And the chord RB intersects with chord DQ at 90 degrees, at point C at 90 degrees, because we have at the point of intersection all the angles that were created equals to 90 degrees. So I write it down, chord RB intersects with chord DQ at 90 degrees. All the angles here equals to 90 degrees. Okay? And the point of intersection is point C. Therefore, according to rule number 5, we have two chords. Chord DQ intersects with chord RB at 90 degrees. Therefore, we can immediately implement rule number 5 on this circle. According to rule number 5, four times r squared equals to dc squared plus cq squared plus bc squared plus rc squared. So I read again the things that I wrote. Angle BCD equals to 90 degrees. This angle is a right angle, it equals to 90 degrees. Chord RB intersects with chord DQ at 90 degrees. Chord RB intersects with chord DQ at 90 degrees. This angle is 90 degrees, this angle is 90 degrees, this angle is 90 degrees, and this angle is 90 degrees. So at the point of intersection, those two chords creating 90 degrees. Therefore, we can implement rule number 5 on this circle. Therefore, according to rule number 5, 4 times r squared, when r is the radius of this circle, equals to dc squared plus cq squared plus bc squared plus rc squared. Okay? So 4 times r squared equals to dc squared. dc equals to 6, so dc squared is 36 plus cq is 16 over 3. 16 over 3 is 5 third, so 5 third squared plus cq squared. cq equals to 8, so 8 squared is 64 plus rc squared. rc equals to 4, so 4 squared is 16. So in total we got that 4 times r squared equals to 36 plus 5 thirds squared plus 64 plus 16. 36 plus 64 is 100, and 100 plus 16 is 116. So I write it down. So in total we got that 116 plus 5 thirds square equals to 4 times r squared. 5 thirds square equals to 28.444. So I write it down. In total we got that 4 times square equals to 116 plus 28.444. 116 plus 28.444 equals to 144.444. So I write it down. So in total we got that 4r squared equals to 144.444. We divide this equality by 4 and we will get the value of r squared. So we got that r squared equals to 36.111. We know that the area of any circle equals to pi times the radius squared. Okay, the formula for the area of any circle is pi times the radius squared. We know that r squared equals to 36.111, so the area of this circle will be equal to pi times 36.111 square units. Okay, the area of the circle equals to pi times the radius squared. We know that r squared equals to 36.111, so the area of the circle will be equal pi times r squared, and r squared is 36.111, so the area of the circle equals to pi times 36.111 square units. So in terms of numbers, the area of the circle equals to 113.45 square units. Okay, so the area of the circle equals to 113.45 square units. Okay, again, the area of this circle equals to 113.45 square units. Okay, now I will summarize the lecture. Actually, we wanted to find out the value of the area of this circle, and inside this circle we have a shape. We know that two angles inside the shape equals to 90 degrees. They are right angles. Side AD of the shape equals to 4 units, side DC equals to 6 units, and side BC equals to 8 units, and we want to find out the area of this circle. Okay. First of all, we define the theorem of one-sided angles. So actually if we have two lines, line A and line A and line B, and we have the third line, line C, that intersects with line A at point M, and it intersects, line C intersects with line B at point N, then they actually create two one-sided angles. Angles alpha and beta are defined as one-sided interior angles, and rule number one states that if the sum of those two angles equals to 180 degrees, then you can say that line A is parallel to line B. The same rule applies for one-sided external angles. Those angles alpha and beta are defined as one-sided external angles. They are defined as one-sided because they are from one side of line C. Both of them are in the left side of line C. For that reason, they are defined as one-sided angles. So rule number one states that if the sum of the exterior one-sided angles, that is to say if alpha plus beta equals to 180 degrees, then line A is parallel to line B. Okay, so actually I'll read rule number one again. Rule number one states that if the sum of the two one-sided, no matter if they are internal or external, if the sum of those two angles alpha and beta equals to 180 degrees, then line A is parallel to line B. Okay, if the sum of those two angles equals to 180 degrees, then line A is parallel to line B, and the same rule of one-sided interior angles. If the sum of alpha plus beta is 180 degrees, then line A is parallel to line B. And we actually implemented rule number one in our circle, because we actually have here two angles that are right angles, and the sum of them is of course 180 degrees. So we have those two angles are defined as one-sided angles, and the sum of them is 90 degrees plus 90 degrees is 180 degrees. So according to rule number one, line segment AD is parallel to line segment BC. Okay, so in the next step we connected together points A and C by a straight line, and we also connected together points D and B by a straight line. We actually can say that in those two right triangles we have angle BOC that is equal to angle DOA. Those two angles are equal to each other because they are vertex angles, and according to rule number 2, vertex angles are equal to each other. What are vertex angles? If two lines are intersecting at this point, then at the point of intersection they create 4 angles, 1, 2, 3, 4, and angles 1 and 3 are defined as vertex angles, and according to rule number 2, vertex angles are equal to each other, and also angles 2 and 4 are defined as vertex angles, and according to rule number 2, vertex angles are equal to each other. Okay, so actually, as I've already said, rule number 2 states that vertex angles are equal to each other. So actually, those two angles alpha and beta are defined as vertex angles, and according to rule number 2, they are equal to each other. That is to say, alpha equals to beta, and the other pair of vertex angles are those two angles. They are also defined as vertex angles, and according to rule number 2, they are equal to each other. So we actually implemented rule number 2 in our circle because we have those two angles that are defined as vertex angles, and according to rule number 2, they are equal to each other. Okay, then we have rule number 3 that states that alternating angles between parallel lines are equal to each other. What are alternating angles? Alternating angles, here alpha and beta are interior alternating angles. Whenever you have two lines, line A and line B, and you have line C that intersects those two lines, if the angles alpha and beta are the opposite sides of line C, then they are defined as alternating angles. Angle alpha and angle beta are on the opposite sides in relation to line C, the red line C. They are in two opposite sides, and therefore they are defined as alternating angles. Those two angles are interior alternating angles, and actually, according to rule number 3, if line A is parallel to line B, then those two interior alternating angles are equal to each other. And we have the other type of alternating angles. Here we have angle alpha and angle beta that are defined as exterior alternating angles. And according to rule number 3, if line A is parallel to line B, then alpha equals to beta. Okay, so we actually implemented those rules in our circle because we know that we have already proved that line segment AC is parallel to line segment BC. So here those two angles are alternating interior angles, and according to rule number 3, they are equal to each other. And also those two angles are defined as alternating angles, and according to rule number 3, because of the fact that AD and BC are parallel to each other, those two angles are equal to each other. Okay, so we actually proved that angle CBO equals to angle ADO and also angle DAO equals to angle BCO, because those angles are alternating angles and they are equal to each other, and also those two angles are alternating angles, and according to number 3 they are equal to each other. Okay, so we actually proved that three angles in this green big triangle are equal to three angles in this small green triangle. This angle is equal to this angle. Those two angles are equal to each other, and also those two angles are equal to each other. So three angles in this green triangle are equal to three angles in this green triangle. Therefore, we can say that the big triangle is similar to the small green triangle, or triangle BOC is similar to triangle AOD. And whenever you have two triangles that are similar to each other, then the following relationship exists between the sides of those two triangles. AB over DE equals to BC over DF equals to AC over DF. Okay, so we implemented this similarity between those two green triangles in our circle. We can say that OB over OD equals to OC over OA, that equals to BC over AD. Okay, we have this relationship between the two green similar triangles, and therefore we deduce from the equality that OC is twice the size of OA, and OB is twice the size of OD. If OD equals to A, OB equals to 2A, and if OA equals to B, then OC equals to 2 times B. Okay, and we actually then we know that angle ADC equals to 90 degrees, therefore triangle ADC is a right triangle, and we can implement the Pythagorean theorem in this right triangle. According to the Pythagorean theorem, the square of the hypotenuse, that is to say AC square, equals to AD square plus DC square. Okay, AC square equals to AD square plus DC square. And we found out that the value of B is 2 over 3 times root 13, while the value of 2 times B is 4 over 3 times root 13. Okay, the value of B is 2 over 3 times root 13, while the value of 2 times B equals to 4 over 3 times root 13. And then we know that angle BCD is a right angle, is equals to 90 degrees, and therefore triangle BCD is a right triangle. So again, we can implement the Pythagorean theorem on the right triangle BCD. According to the Pythagorean theorem, the square of the hypotenuse of right triangle BCD, that is to say DB square, equals to the sum of the squares of the perpendiculars, equals to BC square plus DC square. Okay, DB square, the square of the hypotenuse, equals to the sum of the squares of the perpendiculars in the right triangle BCD, equals to BC square plus DC square, equals to BC square plus DC square. And again, we have all the sizes of all the sides in this right triangle, we know that BD equals to 3B, DC equals to 6 units, and DC equals to 6 units, and BC equals to 8 units. So we can put the data in this equality, and we found that A equals to 10 over 3 units, while BO equals to 20 over 3 units. Okay, again, and then we actually copied this drawing here, and then we actually extended line segment AC until it touches the circle at point P. We created new line segment CP, and we calculated the value of line segment CP according to the fourth rule. The fourth rule states that if two chords, chord AB intersects with chord CD at point O is the point of intersection between those two chords, then the following rule is true, that is OA times OB equals to CO times DO. Okay, that is according to rule number 4, and actually in our circle we have chord AP that intersects with chord DB at point O. Point O is the point of intersection between chord AP and chord DB. Therefore, according to rule number 4, OA times OP equals to DO times OB. Okay, that is according to rule number 4, AO times OP equals to DO times OB, and again we have all the values of all the line segments here. We put the data in this equality, and we found out that the value of line segment CP is actually 16 over root 13 units. Okay, then in the next step we extended line segment DC until it touches the circle at point Q, and again we can implement here rule number 4, because chord DQ intersects with chord AP at point O. Point O is the point of intersection between DQ to AP. So according to rule number 4, AC times CP equals to DC times CQ. Again, AC times CP equals to DC times CQ, and we have all the values of the line segment except for CQ. Okay, so we put the data inside this equality, and we found out that the value of CQ is 16 over 3 units. Okay, the value of CQ is 16 over 3 units. And then we extended line segment BC until it touches the circle at point R. So we created line segment RC, and that the value of the size of it is missing, so we implemented rule number 3 in order to find out the value of line segment RC. Actually, chord RB intersects with chord DQ at point C, so according to rule number 4, DC times CQ equals to BC times RC. Okay, DC times CQ equals to BC times RC, And again, the only missing line segment is RC. We know all the values of the other line segments, and we found out that the value of RC equals to 4 units. Okay, so actually found out the values of all the line segments in this circle, and the only missing thing is the radius of this circle. In order to find out the radius of this circle, we implemented rule number 5 in this circle. Rule number 5 states that if two chords are intersecting each other at 90 degrees, that is to say, if chord AB intersects with chord DC at 90 degrees, at the point of intersection, point O, they create 90 degrees with each other. All the angles, 4 angles here, equals to 90 degrees. So if this is the reality, then the following equality is true. 4 times r square, when r is the radius of the circle, equals to AO square plus BO square plus CO square plus DO square. Okay? And actually, in our circle, angle BCD equals to 90 degrees, so actually all the angles here are 90 degrees at point C, and the chord RB intersects with chord DQ at 90 degrees. C is the point of intersection. So according to rule number 5, 4 times r square equals to GC square plus CQ square plus BC square plus RC square. Okay? 4 times r square equals to DC square plus CQ square plus BC square plus RC square. Okay, and again we have all the values of the line segments in this equality. We put the data inside this equality, and we found out that r square equals to 36.111, and the area of any circle in the world equals to pi times the radius square. We found out that the radius square equals to 36.111, so pi times r square is pi times 36.111, because r square equals to 36.111. So we found out that the area of this circle is pi times 36.111 square units. So in terms of numbers, the area of this circle equals to 113.45 square units. Okay, the area of this circle equals to 113.45 square units. Okay, thank you very much.